explain what Fourier cosine series and Fourier sine series are. Fourier sine series. Let me try to explain what this means. If you have, let's say, if you're given a function which is an even function, in that case, how does your function f of x's Fourier series look like? Well, Fourier series is a0 plus sigma n from 1 through infinity of an cosine n pi over lx. And then you're supposed to have plus bn sine n pi over lx, right? That's the full Fourier series. However, if the original function is even, then you wouldn't be getting any odd terms, right? If you calculate the bn's, they all turn out to be 0, so you're only going to end up with this, okay? So that's the first observation. That's something that we already learned, okay? When we were doing Fourier series, I already explained that this is what happens if your function is even. What happens if the function is odd? This time, what becomes 0?
an cosine becomes 0.
An becomes 0, and then
bn of sine.
a0 will also become 0, because a0 is a special case of an. So this will be 0, that will be 0. But this time, bn will be the one that's not 0. So you're going to end up with n equals to 1 through infinity of bn sine n pi over l x. Okay? So that's something that we observed already. And if you recall these two properties, now we are ready to define what Fourier sine series and Fourier cosine series is. Okay? So here's what you do. Okay? So what you do is, suppose your function f of x is defined on 0 to L. So you have a function which is only defined on one part. Not both, but just one side. Okay? Then that means you're free to define what the function is on the left side, right? You can extend it. And of course, you can just write it as anything, but there are two interesting cases. There's a case where you can extend the function as an even function, or you can also extend the function as an odd function, right? There are two ways, two interesting cases. That's not the only one. There are like infinitely many possible choices for the left side, but there are two interesting cases. And here's how it works. The Fourier series of the even extension of f of x. So you take the even extension of the function f of x, and if you take the Fourier series, what are you going to get? What terms would you get if you take the Fourier series of the even extension of f of x?
Cosines.
No, if it's even, which one do you get? Oh, you said cosines?
Yeah.
Oh yeah, cosines, yeah, of course, cosines. I thought you said sines, okay. Alright, so you're only going to get cosines, right? So you call this series what? It is called Fourier cosine series. Simple, right? Yeah. And now you kind of know what I'm going to say next, right? The Fourier series of, trying to complete my sentence. The Fourier series of the, what?
Odd extension.
Odd extension of f of x is called Fourier
Sine series.
sine series. Okay? That was good. All right, so let's actually do it. Let's think about a very simple case. All right. So let's see. Example 1. Find Fourier cosine series of f of x equal to x on 0 to 5. Let's think about this. So you have a function defined as x from 0 to 5, and your goal is to find the Fourier sine series, the cosine series. Okay? So what do? Well, first, we know that the only thing that we're interested in is this a0 and a1n. Because it's a cosine series, you're not going to see a sine at all. So you only need to use the formula for an, which is 1 over L from negative L to L of f of x times what? Cosine n pi over L x dx. Got that? That's the formula we have to use. Now before we use the formula, let's try to simplify this integral a bit. Now, we're talking about not the original function f of x, but this is really the even extension of f of x, right? So if this is an even function, what's cosine? Is it even or odd?
Even.
Even. So if this is even, that's even. If you multiply, you get even function, right? You get even functions, and therefore, when you integrate, what do? Yeah?
Multiply by 2.
Multiply by 2, yeah, exactly. Multiply by 2 and integrate from 0 to L. Right? So that's the formula you will be using every time you're being asked to do the Fourier cosine series. Right? Because you're taking the even extension, you always end up with this formula. Okay? So you may just skip this process and just start with this and just say this is the formula for the Fourier cosine series. Yes?
Can you ever take an odd extension of an odd function, or is it always opposite? So like
No. I could have said find the Fourier sine series of this. Then instead of cosine, you'll be doing sine.
yeah,
It'll be 2 over L, 0 to L, fx,
sine.
sine n pi over L.
I just wasn't sure.
Oh, okay, yeah. All right. Let's continue. Therefore, an is 2 over 5. See, our L is from 0 to L. So if I have 0 to 5, L must be 5. 0 to 5. What do I put for f of x? X. Cosine n pi over 5 x dx, which can be easily computed by using tabular integration. So let's use tabular integration. Plus minus d integral x. If you differentiate x, you get 1. If you differentiate x, 1, you get 0. And taking cosine n pi over 5, if you integrate this, that's sine. But be careful, every time you integrate cosine of something times x, this coefficient has to be put in the front after flipping it. Okay, so you have to take the reciprocal of this coefficient and put it in front. So it's 5 over n pi times sine n pi over 5 x. Integrate one more time, it's negative. And because another of this pops in front, you have to square it. This gets multiplied every time you integrate, so you have to square it. It's cosine n pi over 5 x is plus minus plus. And for this, you have to go like that and that. and finally that. But this one is multiplied by 0, so that doesn't give us anything, so we only get these two. So let's write down what the integral is. That integral is, so that gives you 2 over 5 was there before, so we have that. And then it's 5 over n pi x times sine n pi over 5x minus 5 over n pi squared. Actually, it's plus because it's negative times negative, so it's plus. And then cosine n pi over 5x. And then you have to plug in 0 to 5. Let's continue. Now when you plug in 5 here, you get sine n pi. What's sine n pi? 0, right? When you plug in 5 here, 5 and 5 cancels, leaving you with sine of n pi. And I said this appears frequently enough that you should probably memorize it. I don't know where to write this, but maybe I should write it here. So sine of n pi is what?
0.
0. Cosine of n pi is?
Negative 1 to the n.
Negative 1 to the n. Good. So that's what we need. And then you have 2 over 5. Right, first, when you plug in 5, that's 0. We just agreed that. And when you plug in 5 here, 5 cancels, and it leaves you with cosine n pi. And I just said, I already said that cosine n pi is negative 1 to the nth power. So you have 5 over n pi squared, negative 1 to the nth power, minus. Now this time when you plug in 0, 0 goes in here, and 0 times anything is 0, so that's a 0. When you plug in 0 here, what's cosine of 0? 1. So you have to subtract 5 over n pi squared. Why did I put squared here? Sorry, that was a mistake. No, that wasn't a mistake. Sorry, okay. This is times 1. Okay, so that's it, right? If you want to simplify this, you can simplify it as, see, 5 squared is 25. 25 divided by 5 is 5. And you multiply by 2, that's 10. So you end up with 10 over n squared pi squared. N squared pi squared. That's common for both of them. But then you have negative 1 to the n minus 1. So that's what you would get if you simplify it. And I almost thought that we were done, but that's not actually true. See, we're trying to find the cosine series, right? In cosine series, you have two things that you have to calculate. You have to calculate an, and you also have to calculate a0. So we will have to calculate a0. Let's continue and calculate a0. You use the same formula for a0. You still use this. The only difference is for a0 is cosine 0. What's cosine 0? It's 1. So for a0, you will be doing 2 over 5, 0 to 5 of x times 1, because cosine of 0 is 1. And when you integrate this, this is 2 over 5 times 1 half x squared, 5 and 0, and you end up with 2 and 2 cancels, 5 squared is 25, 25 divided by 5 is 5. So that's your a0. Okay? And therefore, putting all together, what is the answer? Answer is f of x equals to a0 over 2. So you put 5 over 2 plus sigma n from 1 through infinity. And you have an, which is, what's an? An is 10 over n squared pi squared negative 1 to the nth minus 1 cosine n pi over 5x. Okay, so that is the Fourier cosine series of the function given. Now, what's the significance? Well, the significance is that if you actually took this right side, this big series, and maybe truncate it to after like 200 terms or 500 terms, whatever, and if you drew that graph from 0 to 5, you'll see that that graph is almost identical to the original graph, which is y equal to x. Okay, that's the significance. Okay, so you have a way to represent a given function as sum of cosines by using this all these steps. That's what Fourier cosine series is.